Here. Hi, you're in the Introduction to Real-Time Applications in the IETF. Thanks for coming. I just want to go ahead and start out by saying that we have a pretty large slot here. I'm probably not going to fill it completely, so feel free to get to the microphone and, at any point during the conversation, talk to me about anything you want to. I apologize, I had to take the front mic because they don't seem to have the wireless ones out just yet. So, real-time and applications and infrastructure. What are we doing here? What's the area about? This is all about creating tools to let people collaborate with each other in real time with minimal delay over the internet. So this is, talking two-way video, multi-party video, gaming, live collaborative music, which there's actually, if you do a web search for live virtual choir, you'll see there's some work that's been going on in this area that's pretty cool to watch. And instant messaging. So basically anything where you have interpersonal communication where delay is a factor, where you don't want to have to wait for things to show up. So what are we doing here? We're not actually defining, architectures or services. We're actually defining the protocols that make building blocks for making all of this possible. This is things about finding out your location information, being able to share it in a way that protects privacy, advertising what services are available, where you are on the network, physically on the globe, that kind of stuff, getting emergency calls to where they need to go, and basically allowing people to communicate how they want to communicate, when they want to communicate, and whether they want to communicate at any given time. So what's the name about it? It is kind of a mouthful, real-time applications and infrastructure. Real-time is we want to make sure that this is going to happen fast enough that you can have a real conversation. And especially when you're talking about voice and video, this needs to be really short. We're talking like, 100, 200 milliseconds. The applications are things like voice over IP and telephony, video calling, IM, presence, emergency services, games, etc. But there's also a need for a network infrastructure behind all of this, things that let you find out your physical location, things that can make assertions about your identity, and things that allow you to find the right person when you want to talk to someone. So today we're going to talk about moving the actual media around, the voice and the video, about how you set these sessions up, these voice, video, etc. sessions, how you exchange instant messages and presence information having to do with both those instant messages and your availability for talking, voice, video, etc. And how we handle things like location, privacy, emergency services, and other service-related stuff. So before I dive into that, any questions about just the overall, what we're going over today? All right? So what does RTP do? RTP is the real-time protocol. It carries around time-sensitive media information, voice, video, that kind of thing, while preserving the timing information so that it can be, first of all, reassembled in a way that sounds natural at the other end or looks natural at the other end, and secondly, can be synchronized with other streams. So for example, I'm sending a voice stream and a video stream. There's timing information in there that lets the far end make sure that it's playing out the voice and the video at the same time. So my lips are going to match the voice that I'm making. So the diagram here is basically just showing you have, for voice, for example, a microphone with sort of an analog input. This ends up getting digitized, put into packets, sent across the network. This is all done over UDP. So, it's an IP network. There's no time guarantees. There's no ordering guarantees. There's not even a guarantee something's going to arrive. So things sort of show up at the other end, in the jumble that you get out of an IP network. And then you have, a means to basically take these things, reassemble them in the right order, sort of smooth over where things haven't shown up, and then play them out at the far end. There's, a similar approach that takes place for video. So what does it carry? Well, there's, in addition to the actual sampled information that I was talking about, there's a header that contains things like sequencing information and timing information that allows you to do the reassembly I was talking about before. Now that's the actual media, how you're getting things from point A to point B in terms of the voice and video. But you also have to figure out how you're going to do this, what you're going to send, whether it's going to be voice and video, what codecs you're going to use, and finding the right people. And that's where the rest of the whole suite comes in. So to actually set up these sessions in the IETF, we have something called the Session Initiation Protocol, or SIP. And let's say I want to talk to Radia. And what I'm going to do is I will use the SIP protocol, my device will use the SIP protocol, to do two key things. The first is to find the device or devices that Radia wants me to use to actually communicate with her. And then once we've done that, it's used to negotiate the session, to negotiate what capabilities her device has in terms of SIP extensions, in terms of whether it wants to do voice, whether it can do voice, which codec is going to use, and that sort of stuff. So if we look at how this is going to, sorry, I got ahead one slide. So in terms of finding the right device, this is something that we haven't really standardized. This is a place where we believe there's room for lots of differentiation within different implementations. The idea is, if I'm trying to get a hold of Radia, it's kind of up to Radia's server to know how she wants to be reached. Now, there's some support built into the protocol for doing some kind of advanced searching type stuff. You can, when a call comes in, there's specific protocol support for sending it to multiple endpoints at the same time, so they all kind of ring at the same time. You can do things sequentially, and you can combine these where, for example, if I'm going to, call Radia, maybe it rings her desk phone or her cell phone at the same time, and then after a short period of time, it stops both of those and rings her home phone instead. And these are all done in a way that basically the protocol makes sure that the negotiation works properly across all of those devices. Now that said, while this is left up to the discretion of the person you're calling, there are a couple of tools that we've put in that allow some specification of how this should work. They're optional, but they're kind of a nice way to determine things like we have a way when a device registers with a network, it can say, I can do video. This is the the callee capabilities, callee device capabilities. And then when I want to call, I can say, I'm trying to reach Radia and I would prefer to reach a device that does video. And so her end proxy is going to determine, okay, well, I'm going to go ahead and send it to this device and that device in preference to her home phone, which I know doesn't do video. And there's also, we'll get into the whole notion of presence a little bit deeper later, but the idea of when Radia publishes her availability, whether she's online, offline, willing to talk, she can also include information in that document that says, and I can do audio, as an example. So looking real quick at how this looks when we go through the network, with SIP, when I'm going to make this phone call I was talking about, trying to reach Radia, I'm basically going to have the SIP signaling go up through, usually it's going to go through my domain's proxy. Anyone who's familiar with the way email works, this is a very similar sort of setup, right? It's I'm going to send things out through my local server. It's not mandatory, it's not a necessary part of the protocol, but it's something that most people end up doing. And then based on the address that I gave for Radia, which looks an awful lot like an email address actually, it's SIP : and Radia at domain, it's going to use DNS to route that to her domain, the proxy in that domain, which is then going to apply the preferences that she has. In this particular case, she set it up so that it's going to always ring her home phone and desk phone simultaneously. And in this example, she picks up her desk phone, the home phone stops ringing, and the proxy takes care of this, send signaling there. It says, don't ring anymore. And then you have the voice call set up between the two of us. And this is the RTP right here. And that's it on the basics of SIP. Does anyone have any questions on that before we move on to the actual session descriptions? Okay. So the next thing down is the session description protocol. And this is, so you can think of SIP as kind of, going back to the email example, this is kind of like your SMTP headers. And then SDP is kind of what's carried in the body. I mean, it literally is a body, if you look at the way this thing is formatted. And this describes the session that you want to set up. It's going to say, well, sorry, getting ahead again. And it's used in a couple of different ways. The first is you can declare sessions. This is usually used for like multimedia sessions where there's something it's not heavily used, but there's a session announcement protocol where you can basically put out descriptions of ongoing multicast sessions that people can join, and basically it's just here are the parameters if you want to join in, listen to this. And then there's a more descriptive form of SDP that's used for negotiation of sessions, where you're going to have a two-way call between two parties, for example. You're going to use this to perform negotiation. And you say things like, I'm willing to do one audio stream and I'm willing to do one video stream, and sort of, here's the parameters within that I'm going to need to apply if I'm doing audio. And this is, like I said, this is used in negotiation. We have an entire framework that actually describes how you use this SDP to perform this offer-answer negotiation. And this is kind of a simple, high-level example, but you can sort of think about it as, if I'm, again, calling your audio, and I want to do a voice and video call, right? So I send over SDP that says, I'm willing to receive voice encoded, with this codec and that codec on this port, and I'm willing to receive video encoded this way on this port. And I send that over to her phone as an offer. And then the phone processes that, and either because it can't do video or because Radia has set it up not wanting to do video right now, it comes back and says, sure, I'm okay doing voice, I'm not going to do video, and here's how I need the voice to be encoded when you send it to me. And so this is, just sort of the overall gestalt of how the SDP offer answer works. Now this is used not just in SIP, but also in, moving on to the next thing here, WebRTC, which is another set of session setup that we're kind of working on in the real-time applications area. And this is somewhat newer. What is this about? Well, this is about being able to perform real-time communications in a web browser without plugins or add-ons or anything like that. So the idea is, if you're familiar with just overall browser architectures, usually nowadays when you go to a web page, you're getting some HTML, but you're also usually getting a whole bunch of JavaScript that sort of drives the way the entire page behaves. And then these pieces of JavaScript, they can interact with the web server that they came from to send and receive additional information. The idea here is that we're adding in, and this is just to back up, the WebRTC stuff and RTC web stuff are complementary efforts being performed in the IETF and the W3C. So there's a set of APIs being done inside the web browser that allow these scripts to basically request access to the network for sending and receiving media. And then there's, on the IETF side, the description of all the stuff that's going on the wire. So the idea here is that you're downloading these scripts along with the web pages, and they are able to set up a direct media stream with another web browser. See if I hit everything. Yeah, so it's, I guess one of the interesting high points here is that we've decided that we're only doing this using encrypted RTP. And the other thing that's interesting here is, in addition to just real-time voice and video, we also have a communications channel for real-time data. And this is done over SCTP, which, if you're not familiar with, is kind of like TCP and UDP rolled up all into one big ball and then put on steroids. It basically does in-order delivery of datagrams, unordered delivery of datagrams. It does stream transmission. And this can be used for some really cool things like real-time gaming. I've seen people use this to try to, there's some efforts to set up things like peer-to-peer networks using just browsers. There's some really nice demonstrations I've seen where people have web pages. You just basically drag a file onto it, send the URL in your browser to someone else. They connect to that, and it downloads directly from your browser without ever going through a server. So some pretty cool stuff that's being done in that area. And then I already covered that part of it, yeah. Now, at its most basic, the way this ends up looking is that you don't really have cross-domain stuff built into the protocol. Now, there's nothing saying you can't put cross-domain stuff in the web server. It easily could turn around and do SIP to some other domain if it wanted to. But just fundamentally, the way this is usually going to end up looking is I'll have my browser connect to let's just say Facebook or something like that. And kind of like they have their IM chat built in there right now, they could easily have that script comes down with also instructions for doing real-time voice and video. And so I would basically have that in the same way that the IMs go through the web server, the signaling information would go through there, go down to Radia's browser. That would this is actually SDP or some proxy for it that we're pushing around. And then that is used in a normal offer-answer exchange to set up the same voice and video streams that we would using SIP. So, any questions on that? I can talk about this for a long time. This is actually what I'm working on mostly right now. So. Right? So, one of the other kind of new things we've been doing recently in the real-time and applications area is telepresence. And this is kind of like the whole voice and video calls on steroids thing, right? It's in addition to just having a video stream that I'm sending over and a voice stream that I'm sending over, you also have a lot of information about how to place the images on a screen, how to place actual, participants' voices within a sound field. The whole idea behind telepresence is that you're trying to make it as close to actually being in the same space as the other people you're communicating with as possible with modern technology. Now, there have been a lot of proprietary solutions around this done by a variety of companies for many years now. But within the IETF, there's now a CLUE working group, it's controlling multiple streams for telepresence. It's a bit of a tortured acronym, but that's actually working on protocols to do this in a standardized inter-vendor way. Yeah, so I got most of this. Things like being able to make eye contact. I mean, if you've worked with voice and video calls before, you probably noticed that most of the time people are kind of looking up in what looks like random places because they're looking at their camera, which is necessarily not where their screen is. So telepresence actually aims to make that a little more natural. Now, what's interesting is that we're still using SIP to set these calls up, right? This is pretty much a normal SIP call from the SIP infrastructure. We're just layering some additional protocols on to be able to gracefully handle things like having, in this example, we have 3 different cameras with some fairly distinct angles associated with them. And, we want to make sure that when they arrive at the other end, they're going to be shown in a way that makes those angles somewhat natural. But we've got 3 video streams and 1 voice stream in this particular example to make this conference setup work in a very natural way. Questions, comments? Okay. Now, these two new technologies have been kind of putting a lot of pressure on the way that we've used both SDP and RTP in the real-time area, which is kind of interesting. One of the things is if you think back to that diagram I just showed you, you've got 1 call now, but you've actually got 4 media streams going on. Traditionally, those would each be their own set of UDP ports, which is going to use resources in the local machine. More importantly, it's going to use resources in any NATs between the endpoints. And this ends up, when you start thinking about, within an enterprise, we have a few of these different things. It ends up getting pretty expensive from a resource perspective, just the number of, especially if you have the larger systems. You might have 5 or 10 cameras and 4 or 5 audio streams. You're eating resources pretty quickly. So there's been some work on doing multiplexing. How do you describe that in the session description protocol, because that really hasn't been something we've had to do before. Making sure that it's actually going to work gracefully with RTP when you have multiple streams going all on the same port between 2 devices. So yeah, that's what the multiplexing here is about. We've also had lots of discussions around what we need to have in order to ensure interoperability of codecs. And basically the way that we usually do this when you have multiple options in a protocol is you have one option that is considered mandatory to implement. This is actually, for codecs, end up being somewhat controversial. I mean, there was actually a lot of conversation around whether we even need to have an MTI for these sorts of things. And then, even if you're not following this area very closely, you probably have heard there have been some interesting discussions around which video codec is going to be MTI for WebRTC. So it's been something that we've not previously had to deal with in the area that's sort of come in because of these new technologies. Simulcast, the ability to send streams that are semantically the same thing but encoded different ways. Like if I want to have a stream generated from a camera that is a large stream, and then for other devices a small stream, and have these sent at the same time. That's something that we haven't really had good communications for in the session description before. Being able to put codecs that have different clock rates associated with the same media stream. Oh yeah, when you start to think about, these are UDP packets we're sending, right, with the media, and we have a bunch of them, and they're getting pretty big. We start having to worry about things like congesting the network. So we have, congestion control as applied to real-time media, which is kind of a dicey game because you can't really do exponential backoff when you have only 100 milliseconds or so to get a packet across the network. So you also have, there's been some work done in how do we detect that things are going wrong and basically say we're going to stop sending media altogether. There's some circuit breakers work that's making good progress in determining when you need to just stop the media to prevent destroying the network. And then there's also been some interesting work we've had to do for grouping things together, where we talk about these streams are grouped together for various purposes. It's, things like I mentioned at the beginning, I want to make sure that this video stream and that voice stream are considered one thing for the purposes of making sure that lip sync works. So that kind of stuff. Any questions on any of that I just went? I'm going to go back to it in case anyone wants to. No? All right. So, presence and messaging. These are usually grouped together because they kind of evolved from the same proprietary services. If you think back to like AOL Instant Messenger and Yahoo Messenger and those sorts of things, usually you were able to go to your list of friends and see who was online at the moment and be able to start chatting with them over a text chat session, right? Now, that said, we've actually, when we were working on presence in the IETF, expanded it to deal with all forms of communication. This is, whether I'm willing to communicate via not just IM, but voice, or whether I can do video, and that kind of thing. What mechanisms do I prefer right now? Am I busy? Is it something where I should only be reached for urgent matters? Am I in a loud place that would make it difficult to hear you, or am I engaged in some activity that would maybe impact your decision to contact me? So that sort of stuff is all information that we're putting out in presence. And this can be a combination of both the, I'm at lunch for an hour sort of stuff, something that's going to have a natural timeout associated with it, along with, things that I've actually pushed into the server that have a bit more hard state associated with them, like I'm on vacation until I tell you otherwise. Now, the idea behind this is that, I put this information together, and I have a server that's kind of composing it into a sensible view of my willingness to communicate. But this also can have stuff in there that I might not want everyone to see. I might not want my boss to see I'm at a bar right now, that kind of thing. Or, someone who isn't necessarily someone I want to know anything about me. This might be a stalker. So the idea is we also have included in this the idea of who gets to see not just my state, it's not an on and off thing, but who gets to see what part of my state. So it might be that, Bob can see my personal state. Bob sees that I'm at a bar. Carol sees, what I've designated to be what the people who I work with can see, which is, Carol sees I'm busy, but that's it. And then Mallory doesn't see anything at all. Mallory just is not allowed to see my state. Either gets a dummy state that doesn't mean anything, or actually gets a rejection. And there are two different ways to handle that in presence. Okay? We also have to sort of make managing larger groups of this easier, the concept of contact lists, where I'm going to not just specify rules for who in this large group of people can see my presence, sort of as a batch. Here are my work people, here's what work people can see, here are my friends, here's what friends can see. But also the idea of who I want to get information from. Here's the people that I want to see the presence information for. So we actually have these buddy lists or rosters that we have stored on the server where, with a single message I can say I want to subscribe to the present state of all of the people that you know are my friends, that I've told you who my friends are. And then I get all of that information all at once. Now, one of the things when you start thinking about this is once these lists grow to any reasonable size, the number of relationships scale up extraordinarily quickly. And this is actually one of the challenges, not just from a protocol perspective, but also, putting these types of servers together, it gets, I mean, it's basically a combinatorial explosion. So this is one of the more challenging parts of making presence work. So anything on presence? Dave. So the present stuff that I was talking about specifically was, yes, towards simple. XMPP, and I have, is that the next thing here? Yeah. I'm actually going to talk towards XMPP and simple here in just a second. But XMPP has its own presence built in that is, it's somewhat simpler, which is both good and bad. So it's not as flexible, but with the flexibility comes substantial complexity. So it's a trade-off.
Okay, so the word simple was really all the time.
So the simple chair is sitting like 3 seats behind you. I'm going to lean on him for a moment. The until just recently simple chair is sitting just behind you. Actually, can I get to the messaging real quick, and then the next slide I actually get into a little bit of the differences between those two protocols. So that was presence. We've also got the instant messaging part of things, and messaging we have. And again, this is more biased towards the way that the simple stuff works. Although the session mode is pretty much the way XMPP works. So we have page mode messaging, which in SIP it goes along the signaling protocol, the same way that SMSs do if you're familiar with telephone technology, and it works a whole lot like SMSs. These are just short little messages, usually text, that don't have any real session associated with them. It's kind of a send and forget thing, and if you want to respond, well, you respond, but it's not marked as being part of the same session. There's also session mode, which is basically a chat session with a distinct beginning and a distinct end, kind of like a voice or video call would have. And this, I mean, it's literally using SIP to set up a separate channel over which all of this is sent. There's also, you can compose these together in the same way you would for making like voice and video conferences. You can have basically text conferences or multi-user chat experience. Now, one of the things that's interesting is once you get into session mode messaging, the way we defined it at least, they can be arbitrary content. It doesn't have to be text. You can send video, audio. You can send an entire feature-length movie over this if you wanted to. It's designed for transferring arbitrary content and arbitrarily large content. Okay? Now, what we're doing in the IETF in terms of presence and messaging, as Dave alluded to, there are actually a couple of different efforts here. One is the XMPP work, and this is sort of a more formalized version of, if you're familiar with a Jabber, this is that protocol as pushed through the IETF process. It's based on XML streams over TCP. Basically, it has a fairly rigid client-server architecture. It's basically, it's enforced to be that picture I put at the beginning where I have my client talking to my server, talking to your server, talking to your client. And that's kind of the way it all works. And all the messaging goes between us through those servers. There is some file transfer extensions that go directly between clients, but by and large the messaging just goes end-to-end, me, my server, your server, you. This is very well deployed, especially in enterprises. It's got a pretty high degree of penetration in general. And then the other thing that we have is the extensions that have been added to SIP for presence and for instant messaging. And these it's mostly SIP, but there are some additional protocols here. We have like XCAP for defining who your buddy lists are, the permissions associated with that kind of thing. We have MSRP, which is that protocol I was talking about that we use for instant message sessions where we're actually exchanging messages directly between our clients. Now it is, like SIP, it's a very flexible architecture, which is, it has good points, it has bad points. It does make it somewhat more complex to deploy, but it does also give you a bit more flexibility in how this is deployed. It has fewer deployments overall, but it's starting to grow, especially because the IMS network, the IP voice multimedia network that wireless carriers and a lot of wired carriers are sort of using as the basis for their infrastructure, also has this as part of what they're trying to do. So it's growing. It is growing somewhat slowly, and it's more at the carrier level than at the enterprise level. So that's kind of the answer that I was trying to give to you earlier, Dave. Is that what you were asking about, or?
I wasn't sure what the current status was.
Okay. Well, and I see Keith is up nice and close to the microphone, so maybe he can talk to that a little bit.
Well, all I was going to say is, if you see the words RCS or OMA around, that means simple. Developed simple, but basically based on simple.
So the rich communication services is defined by, that's OMA, right?
No, rich communication services is actually GSMA.
GSMA, right.
But they've taken OMA stuff and built it, packaged it, made it more interoperable.
Right. And this is...
As was developing 10 or 15 years, what you're describing is two independent networks almost identical.
You're talking about the XMPP versus Simple?
Yep.
To some degree. They have different capabilities. I think the big thing to lean on here is that the architectures that you can achieve with Simple are significantly more flexible than what you can do with XMPP. For better and for worse.
I'm going to just say, by the way, on the previous slide, you were likening simple message to SMS.
Yeah.
There is one subtle difference. SMS is always store and forward. Message was not defined primarily to be that, although you could play it that way.
That's true. Yeah. We're kind of at a high level in this particular intro. If we want to get into details, there's a lot of detail to get into.
This is Ben Campbell. You guys made me come up here. I am one of the former Simple Working Group chairs, and am currently one of the co-chairs of XMPP. And I think some of the statements that are made, XMPP does have a lot more deployment. It's, I think, clearly simpler to deploy, but we are seeing Simple work, again, like you said, primarily in more of the telecom-oriented space. And I think one of the big distinguishing things there is most of those spaces were already using SIP-based things for other services. So, if you're already doing SIP, it kind of made sense to continue going SIP when you go into this area. And if you start looking at the presence models, what you can actually express, they're fairly different right now between the two, although the stocks work may harmonize that more.
Paul Kizavant, SIP Core Chair, along with Adam. To me, there's huge technical differences between the two. But from a functional point of view, to me, the difference is that Simple is part of SIP, in effect, and therefore it's built on the same addressing scheme as SIP, whereas XMPP has its own addressing scheme. And so, if you want to talk to the same people that you talk with voice with, then or video, then the SIP stuff works better for that. Yes, Simple is part of that. You can just say, well, I want to switch from text to voice or video and back. You can just do it. If you want to, but if you use XMPP for your messaging, and you use SIP for your voice, and you want to flip back and forth, then your address book has to have separate addresses for each person. If you want to flip back and forth, you've got to set up another session when you switch, and so on. So, from that perspective, I always thought that Simple was the better way, but on the other hand, XMPP is way more deployed, and it's simpler to build, and in large measure it's one in the messaging business, except in that kind of carrier business which is mostly built on phone numbers. Yeah.
Dave Crocker. So this is an intro session, and I'm going to ask a non-intro question just to ask it. I don't expect you to really pursue it, but the addressing argument is a classic, powerful one, and the convenience of continuing to use the same address for multiple services is appealing. I assume, therefore, that there will soon be an effort to do a SIP-based email service.
All right then.
By the way, that was actually intended, I mean, besides being generally troublemaking, it was intended as a different kind of tutorial about the IETF.
Well, to be fair, there has been a lot of conflation of namespacing here, where a lot of people believe that if you have a SIP address, a@b.com, then I will also be reachable at the email address, a@b.com. And in fact, there are some very large corporations that have deployed simple infrastructure into a lot of enterprises who have made exactly that conflation very real. So the answer is, yeah, a lot of times you can do that, even though it's not necessarily part of the protocol to define them to be equal. Of course, you get that out of XMPP as well. So, mostly because these all use identifiers that look very similar. It's always username at domain with, possibly some decoration on either end. But at any rate, it's actually all a very good lead into what we're doing now. This is new, the SIP to XMPP interoperation work, which is actually, I say it's new. It's new as a working group. Now, there's actually been a lot of work, probably over the past, I'm thinking 4 or 5 years, more in the individual draft space, of people working together to try to define how you would interoperate these two protocols, how you'd interoperate both the presence and the messaging between SIP and XMPP, because they both do have niches, and they both, have reason to want to talk to the other. So this stocks group, like I said, it's new, and it's going to be working to interoperate SIP and XMPP in a way that makes sense. So if you're interested in this space, if that conversation piqued your interest, please start participating in stocks, because there is some work to be done here. All right, moving on to location and privacy. So we have a set of protocols that we've defined in the real-time applications area that let an endpoint learn where it is, physically on the planet without having GPS chip necessarily. And the idea is that it uses things like HTTP or DHCP to find out. Basically, it queries a server, and that server, based on its knowledge of the network infrastructure, based on, I know that this has to be associated with that particular room or that particular building, I can give you, a good approximation of where you are on the planet, and return that information. So we also have protocols that let an endpoint, once it's discovered that information, send it to other nodes in the network. I want to go ahead, I'm making a phone call, and I'm trying to call, a pizza delivery service, and I want to get to whatever branch is closest to me. So I'm going to deliver this location information as part of my call setup, and it's going to route to the closest thing to me. We've also been very careful in conjunction with this to define policies around what people who receive this information can do with it, who they can share it with, that kind of stuff. And this is where the GeoPriv, the name of the working group. Geo stands for geographic location, Priv stands for privacy, and we've considered this to be important that these go hand in hand. So it's basically whenever you have location, it comes with a set of rules about how you're supposed to use that location. And we also we have some work that allows you to find what service is available physically in your area, based on your location information, and this is using the LOST protocol. Finally, and I got it empty on the slide one too many times, I apologize. This is also another new effort we have going on in the IETF. Well, I say new. There's some new work going on in the area of calling party identity, and a large part of this comes down to the fact that just like an email, it's very easy to spoof the from field in a SIP message. So, I can claim to be the White House and just send out a message, and there's nothing that you can do to verify that I am or am not. But with SIP's increased deployment, we're seeing a lot more abuse of this, basically, where you have robocalls that are coming in from arbitrary phone numbers that aren't actually real. You have people using this to set their calling number to someone else's number and calling their voicemail service so they can listen to their messages. You even have banks that are using calling number as part of their authentication schemes, and obviously this is a real problem. I mean, we have organizations like the FCC and the ITU stepping in saying we need to have a solution to this. Now, it's not that we didn't think about these things when we were working through this. So there was some early work that allows proxies to add, this is who this person is. We had some further work that basically has proxies that can put cryptographic signatures on saying, yes, this from field, I vouch for the fact that this from field is valid. And you can say, okay, well, the person who vouched for this is the person, is the domain that's in this email address or in this SIP address in this context. But the problem is we're not talking about those sorts of addresses, right? We're talking about we have real phone calls coming in on cell phones using regular phone numbers which don't have a domain. So it's not, you can't have someone saying, I as example.com assert that this person owns that phone number because they have no authority over that phone number. So this has actually been, there's that, just to give it a quick mention, we also have something called Viper we've been working on that allows you to sort of bind the identity of repeated SIP phone calls to an existing phone number, but this really only works for that scenario where I have a relationship with someone else as opposed to these robocalls or these, I'm trying to spoof a voicemail server or a bank. Dave?
Did you say Viper work is continuing?
I think that's going on. Do we have anyone here who was working on, Colin, thank you.
For some epsilon above zero, continuing would be the answer. There are multiple people that are shipping products based on it. It's working fine for them. The standards are moving along slowly. They're currently blocked waiting for reload, which is in auth 48, where I assume auth 48 is moving from 48 days to 48 months.
But in any case, that was kind of the background of what we've done historically for this, none of which is actually working for the real problems that we have with phone numbers right now. So we have also started a new working group called STIR, which stands for Secure Telephony, Secure Telephone Identity Revisited, that is specifically looking to address this problem for phone numbers that are going to give service providers tools for verifying calling party identity on regular phone networks as opposed to just pure IP calls. Any questions on that? All right. So, Keith.
Yeah, one thing I would say is that half the working groups in RAI are set up to basically correct the faults we made in SIP right at the day one. And the identity really is part of it.
That's one way to put it. Yeah, we are refining the protocol to address real-world problems.
No, there were some fundamental design decisions that were wrong in SIP, and basically we're living with them.
Thank you, Keith. Very astute observation.
That's true in most areas.
Yeah. So we also have, as I pointed out, as these things get additional deployment, we have the need to make emergency services available to people. And a large part of this is being able to find the right emergency responder for the right location at the right time. And to provide those responders with the location that you are. Now obviously that ties back to the location information that we were talking about before. But we also have to do this in a way that addresses historical legislation around this. There's a lot of body of law in a whole bunch of different countries that talks about how emergency services have to be provided. And you also have people very interested in providing sort of the next generation of emergency services on top of this. We were talking about instant messaging. There's been a lot of discussion around how can I get things like instant messages, XMPP instant messages, SIP instant messages, SMS, into PSAPs, the answering points for emergency calls, so that they can field emergency information using things other than just plain old voice calls. So we have some interesting challenges in this space, in addition to having to meet old requirements, getting some new features in there as well. And then finally, even though it's not exactly a technology area, something that we've been doing in RAI that actually works pretty well for us that we wanted to highlight here is we have a working group called Dispatch. Now, if you go back a few years, we actually had a lot of work coming into the RealTime area, and it was kind of frenetic, and things were kind of ending up just in arbitrary places. People would show up in various working groups, and there wasn't necessarily a good place to start, a good venue when you had something to do. A lot of times they just showed up in SIP because, well, we're using SIP, so SIP, of course. So what we did a few years ago is we restructured the area to have among other things, this dispatch working group. And the idea is, if you have some new work that you're bringing into the real-time applications area, and there's not a clear existing working group that's supposed to work on it, if it's not obviously in someone's charter, then you bring it to dispatch, and the working group basically helps you figure out what to do. It's sometimes they say, oh, well, based on what you're trying to accomplish, this obviously belongs in this existing working group over here, and they send it off to that group. Sometimes they say, oh, this is good work, and we have enough people here who have expressed interest in working on it, so we're going to form a new working group, a new relatively short-lived working group to go off, work on this one problem, publish the documents, and shut down. And we've done a lot of those sorts of things. In fact, when I flip through the next, I'm going to have the list of working groups we have here. You'll see there are a lot that are basically shutting down because we have things that pop up, do something small, and shut back down. And then sometimes we actually have things where the working group comes in and says, no, this isn't something that should be done. Either there's not enough interest, or this is architecturally not a good idea, or that kind of stuff, and they just say this isn't going to move forward. So as such, the dispatch working group, it doesn't actually produce any documents. All it is a working group to kind of, create new working groups or send work to existing working groups as necessary. Formalized red tape. Yes.
Does it know the AD saying this belongs to this working group?
So the area director is very, very closely involved in the way dispatch works. But the area director wouldn't have the ability to, for example, determine that there is enough interest in working on a problem to move forward with it. And that was one of the big things. You'd have people showing up with, here's a project I want to work on, and it might just be that one person who wants to work on it. And, they might have been able to convince an area director that it's something that should move forward, and then there wouldn't be any energy behind it. Or they, might be that someone showed up with something that, didn't necessarily sound like to the area director something needed to happen, but they would bring it into a larger group, and it's like, yeah, we have that problem too, and you have a group of people large enough to make this happen stand up and say they're willing to work on it, and then you have a working group move forward. So a large part of it comes down to making sure that there's enough interest in the community to have a successful protocol at the end of all of this.
But what's so special about the RAI area that needs such kind of working group, and what do you think has dispatched other areas?
The idea probably could work for other areas. The reason we had to do this is because we did have a lot of work showing up all at once, and we didn't even have the bandwidth for it. And it was hard to determine which ideas would have enough energy to reach conclusion and which didn't. I think, I suspect that's why Colin stood up, because he wants to talk to that point as well.
Well, yeah, the first thing I wanted to say is that dispatch doesn't necessarily say there is enough interest in doing the work. It may leave it to the recipient group to make that decision.
I meant that more in the context of if there is to be a new group formed.
Yeah. But I would also say there's nothing particularly unique about dispatch. the apps area is a working group, as far as I understand, that basically does a very similar job.
Colin Chen, I'm one of the co-chairs of the dispatch working group. It is often perceived, and this is a very common comment we get, is, wow, this is an extra step of red tape. Okay. If you don't want to use the dispatch working group, you're totally welcome to ignore it and just do it like you did it before. The problem is how we were doing it before. We had people coming with the same document time after time after time. For 5 years, they would present it in the SIPing working group, and it didn't go anywhere every single time. And we were trying to break that process and make that a bit faster and easier for people. So dispatch is a tool that's there if you want to use it. All the other normal tools of IETF, it doesn't change IETF process at all. You're welcome not to use it. But it's dispatch in both sense of the words, to send it out to something and to kill it. And that's an important part of how RAI looks at it, is both of those processes. And it's supposed to speed things up. And if it's failing to speed things up, then we should dispatch.
Yeah, just following on from what Colin's saying, the SIP and SIPing working groups used to be the place which ended up basically doing this job, SIPing primarily. But basically, anything you put to those groups ended up in a queue behind the work they were already doing, as is basically what's meant to happen. You're meant to finish the work off you're doing before you start new work. So anything that came along that was completely new, but still ended up going to SIP or SIPing, basically ended up with a 2-year delay on it. So that's why you've got a special group, It's not unique, as I say, but it's a way of actually making sure that if it is something that can be dealt with independently of anything else, it can form a new group, go away and do it.
Thank you. Okay, so that's kind of the, functionally what we work on. What I have remaining is sort of a list of existing working groups and recently concluded working groups. And I'm going to sort of talk through what part of this whole ecosystem they work on each. So within RealTime Media, the actual, how we convey voice, video, etc., we have, I'm going to go ahead and group together AVT Core, AVTX, Payload, and XR Block, predominantly because these actually, all four of those, split off of what used to be called AVT. And they work on the stuff that actually goes in the RTP and the RTCP. The AVT Core is kind of the core protocol part of this. We have extensions to the RTP protocol itself. We have the work around how you encode specific codecs into a payload, which is this payload group. And then we have the XR block, which is basically RTCP, which is a companion protocol for RTP that allows feedback about how the RTP is progressing, how the network conditions are and that sort of stuff. And there are extended block reports that you can use to convey even additional information, and that's what this working group works on. The other two groups on here, codec, is codec still going? Because I know that's
as an it is still open, but what all it's doing is they're not developing any new codecs right now. What they have is there's a characterization document where they're trying to characterize the performance of Opus relative to other things, and that document is keeping the working group open. It is not meeting on any regular basis or anything. It's just trying to finish up that one document and push it out and be done.
Okay, great, thank you. So backing up to what codec did is they actually went and they defined a new audio codec specifically for the internet and published that. If you've heard of Opus, that's what this effort turned out, and as Colin pointed out, we've got some additional characterization work that's coming out of it. But they're effectively done with what they, the core of what they needed to do, and they're just kind of finishing it up now. And then there's the RTC web stuff, which I already covered earlier. Within session control, we have PeertoPeer SIP, which is actually, it defines reload, which is it's a peer-to-peer mesh protocol, along with how you use reload to send SIP directly among peers in this basically large mesh. You can sort of think of it as the same way as, BitTorrent or those kinds of clients are sort of self-organizing. Peer-to-peer SIP is designed to be sort of a self-organizing, effectively serverless SIP network that you can use. M-Music is kind of the core of where all of the session description work goes on. This is the group that owns and works on SDP. There's some other work that goes on there, but that's the preponderance of what M-Music is working on nowadays. Just historically, M-Music is actually where SIP came out of. I mean, before all of this stuff sort of split off, you can almost think of it as the progenitor of most of this entire area. It was kind of the great granddad of all these working groups. SIP core works on extensions and, well, not extensions, fixes to, effectively, the core SIP protocol. So if we discover, for example, one of the things we're going to be looking at probably very soon here is making sure that we handle IPv4, IPv6 transition smoothly. So that kind of thing, where you're talking about, literally at the core of how SIP behaves, we work on that here. We have a working group that's been doing some SIP overload control work, where they're exchanging information among nodes that allows the network to react to overload situations, so that you can get better throughput of good traffic and reduce the chances of things failing just completely. We have STRAW. This working group is defining what SIP intermediaries that aren't just standard SIP proxies can do to sort of maximize the chances of services working through them. There are a large number of nodes out there that, for various reasons, actually end up in the middle of a SIP call. We have basically a call between a client and this node, and then a different call between a client and that same node, and it sort of bridges them together. This is common. PBXs will frequently do this, where you don't end up with a call directly between the two phones. It's kind of, you're talking to the PBX, and PBX is talking to the other phone, and they kind of bridge it together. And this talks about what those, PBXs or other middle boxes that are doing other services can do to make things work more smoothly. And then we have insipid, which is sort of playing in the same space, except for it's just defining a way to, like I said, you might have two calls going on there when I'm talking to Colin through PBX. It allows an identity to basically bind those two things together so that someone looking at the network traffic can say that call and that call are actually part of the same, so that session and that session really are sort of part of the same call, and you can use that for determining, call logging information, et cetera. Okay, within location, privacy, and emergency services, we have ECRIT, which is basically that's you can think of that as the people working on making 911 work, or 112 or 999 or whatever it is in your locality, your emergency number service work for voice over IP. And then we've got the GeoPro stuff, which I kind of covered. This is the work on how you determine and convey geographic location and the privacy information that goes along with it. Within the way that applications behave, we have the call control UUI service, or SIP, and basically this is just defined a means for taking arbitrary blocks of application-specific information and sending it from one endpoint to another. And they're mostly done, as far as I understand things. We also have Salute. Salute is actually a really good example of one of the kinds of little working groups that Dispatch creates. This is a working group that was literally created to produce one document that spoke about how you convey the semantic information about how you want to alert a remote party. Right now, if you look at the way PBXs work, frequently you'll have one ring for an outside call, a different kind of ring for an internal call, someone from your same office. And there wasn't signaling for this, right? So this working group literally just got together and defined a URN that conveys that kind of semantic information so that you can put that feature in your phones if you want to. We've got SIP CLF, which just recently concluded, but what they did is they defined a format for basically logging SIP call log information. This is very similar to if you're familiar with like HTTP logs and the way that everyone uses kind of the same syntax for dumping these things out in a file. We've got one for SIP now, and that's what this group did. And we also have SIP-REC, which works on recording ongoing SIP sessions. The idea here is, when you call into a call center, you'll frequently get that message saying this call may be monitored for quality assurance purposes and that sort of thing. This is to allow you to do that within a SIP infrastructure as opposed to, the old circuit switch PBX type approach. Okay, interdomain routing. So in addition to just using, normal DNS for conveying stuff, when you have federated networks, sometimes you want to use different things than that, especially if you're using, say, phone numbers. And Drinks was working on a means for conveying information about, routing those sorts of calls, and they're mostly done with what they're working on. Viper, we already went over Viper a little bit, and they're also concluding soon. Basically, what it did was it used the PSTN. You'd use a regular phone call to sort of establish some parameters. You could then, when you tried to reach someone over the SIP network, say, oh, and I own this phone number. The reason you know I own this phone number is because I called you from it, and here's what our call was like to prove that I was that person, which is kind of clever. It's more designed for, doing enterprise calls and being able to bind an identity to an existing phone number. And then finally, we have the STIR stuff that I had mentioned earlier, which is trying to solve this problem in a more generic first contact way. Presence and IAM. We have Simple, which, as Ben pointed out, we're actually done with for the time being. That working group has recently concluded. We have XMPP, which is still going on. I don't know if you want to stand up and talk to that or not. No? All right. What? Okay. And then the SIP to XMPP interoperation stuff. And then finally, we have the conferencing, telepresence, and media services stuff. BFCP BIS, another good example of a small, short-lived dispatched group. There was a protocol that we had come up with for conferencing that allows you to do floor control. I want to have the microphone in this conference call, that sort of thing. And there were some changes they wanted to make to it, so they spun up a working group to work on changes to the protocol and publish the documents, and they're mostly done. They're going to be closing that group pretty soon. We've got Clue, which I went over. That's the whole telepresence stuff. And then finally, and I missed one of the badges here, Media Control, which is actually just concluded like 3 days ago. What they did was they defined a means for when you had a media server, something the media goes through but isn't actually talking, signaling to other things in the network, and you have the actual signaling node, you can have the media control protocol actually talks between these two things to allow that signaling node to control the media node effectively. And then just to round things out, yes, we still have dispatch, and that's, we went over that in pretty good detail. So, and that's all I had. If anyone wants to revisit any part of this, I'm happy to talk to it. Otherwise, I wish everyone to enjoy their afternoon. Brian.
Brian Carpenter, speaking as a member of the IETF's Edu team. I have a question to the audience, not to the speaker. This session, in a way, was a bit of an experiment to find out if doing tutorials about what areas are up to is a good thing. So I'd like to ask if people think it was a good thing. Yes. Does anybody think they wasted their time? Great. Yeah.
Those aren't usually.
I know. Okay, thanks. And thanks to you.
Much, Brian.
So 3 quick questions. Does forking work? Why is it called simple? And which will the codec be?
I refer you to Jonathan Rosenberg. Oh, not here, sorry.